welcome back. So let's jump into severe weather and talk about all different types. This section, section 5, is going to be kind of long, broken up into a number of videos. Let's first talk about, and let's go from increasing in severity. Let's just first talk about thunderstorms. There are three conditions, atmospheric conditions, necessary in order to create a thunderstorm. I'm not talking about just rain. I'm talking about a thunderstorm which has lightning, which has rain plus lightning and thunder. So you need warm and humid air available in the lower atmosphere. So you need some air mass moving in that's warm and humid, a lot of moisture in it. That's in the lower atmosphere. In the higher atmosphere, you need cooler air up in the upper atmosphere, cooler air, which is also usually drier. And then you must have some sort of updraft that's forcing the warm air up to the upper atmosphere to where it cools very quickly. It loses the ability to hold all that precipitation, and then it rains. Now, how fast that upward movement is done kind of dictates how much energy is in a storm, thus the severity of a thunderstorm. So you have you have cool air in the upper atmosphere, warmer air in the lower atmosphere, and some way to get that warm air pushed up. That warm updraft cools very quickly. Cooler air can hold less precipitation than warmer air, so all that precipitation is lost in the form of rain. Now, when you have a thunderstorm, not just rain, but a thunderstorm, you get this very somewhat typical, what's called an anvil-shaped cloud to it. So kind of a column that it almost looks like a nuclear explosion mushroom cloud. You get this big column moving up, and it kind of flattens out, kind of peaks on top, like the shape of an anvil, which is a device used in blacksmithing. So you see these on the horizon, you see these out in the sky. These are indications that a thunderstorm is developing. So again, you kind of see again this anvil shape. Here's a little bit bigger, the anvil shape coming up here. It looks very ominous. These things look very Independence Day ominous. And you can see it kind of rises up and kind of spreads itself out. So these have the ability to have a lot of rain, which can cause damage and destruction and death. A lot of lightning and thunder, which can also cause damage, destruction, and death. Wind, which can also cause damage, destruction, and death. So where in the U.S. gets the most thunderstorms? Most thunderstorms. Not just regular rain, but the most thunderstorms. Well, that award goes to Florida. So they have, in some places, over 100 days with thunderstorms. I'm not talking about just rain. I'm talking about thunderstorms. Warm, moist air. They're right near the ocean. Warm ocean currents, very warm areas to begin with. So warm, humid air. And if you get some cold air higher up in the atmosphere and the ability to raise that warm, moist air, you're going to get thunderstorms. So yeah, Florida takes the award there. You can see in Arizona, we do get our number of days with thunderstorms. Phoenix is probably right around this area, 20 to 30. Now, due to climate change, that's actually on the decrease, but this is historical averages. Which, speaking of Arizona, so let's talk about our rainy season. And that's all due to the North American monsoon. That's the official name of it. The word monsoon itself refers to a seasonal change in the direction of prevailing or strongest winds of a region. That's what monsoon means. It doesn't mean rain. It just means a seasonal change of wind patterns. That's all monsoon means. The North American monsoon, that's the name of it. There's different monsoons throughout the world. Ours just happens to be named the North American monsoon. Is obviously a pattern of a pronounced increase in thunderstorms and rainfall over a large area of the southwestern U.S. and northwestern Mexico, typically occurring between July and September. The monsoon doesn't happen anywhere else in the U.S., just in the southwest. All right? Now, it can still rain here, and it's not a monsoon, because, again, the monsoon is not a rainstorm. A rainstorm is not a monsoon. I can't say that enough. Rain is just called rain. A thunderstorm is just called a thunderstorm. But due to the shifting wind patterns, this kind of change in the season, it can create thunderstorms. It can create rain. We get rain here not due to the North American monsoon. It's just during this time from July to September, the shift in wind patterns really increases the likelihood of rain and thunderstorms. So again, the monsoon, as it is, only occurs in the Southwest, in the U.S., nowhere else in the United States. All right. And I'm sure you can imagine that the North American monsoon is the primary water source for desert ecosystems in the region. So most of our water resources in the desert comes during this monsoon. So how does it work? So typically, weather in the United States moves from west to east. So if there's some sort of weather event in the west, a few days later, or about a week later, 2 weeks later, whatever, it makes its way off to the east. That's how it kind of works. So weather, typically, most parts of the year, moves in that direction. However, starting in July through September, because of different weather patterns, you get a high pressure ridge kind of moving up into the area. And when it does, this now circulating air pattern is bringing warm, moist air from the Pacific Ocean and the Gulf of Mexico up into Arizona. That doesn't happen normally. Normally, this air is just traveling over California or parts of Mexico before it hits Arizona. So it's very hot, dry air from California, Nevada, bringing it into Arizona. But again, due to shifting weather patterns, this monsoon ridge, this high pressure system kind of gets pushed up from the south, and this circulating air pattern now, it's bringing air instead of directly over California to where it dries out, it brings it up from the Pacific Ocean, brings it up from the Gulf of Mexico into Arizona. So now we have this warm, moist air over our region. And remember, that's part of the recipe for thunderstorms. That's why we don't get them all the time, but that's definitely a part of the recipe. So you get this warm, moist air. Now we just need the cooler air up in the upper reaches of the atmosphere and a way to kind of lift that warm air up. So this is rain in Maricopa, kind of in the center of Maricopa County. And this looks at averages since 2007. And you can see, as far as averages per month, that during July, August, and September, that's typically, on average, when we have the highest amount of rain. Obviously, that's due to the North American monsoon, bringing up that warm, moist air from the Gulf of Mexico, creating all those thunderstorms, creating all those rain showers. Remember, a rainstorm is not the monsoon. Rain is rain. Thunderstorm is a thunderstorm. But during this shifting of weather patterns, that's the monsoon. It brings this warm, moist air up from the Pacific Ocean, up from the Gulf of Mexico, or the Gulf of California, excuse me. I've misstated that a few times. The Gulf of California, bringing it on up into Arizona, helping to facilitate rainstorms or thunderstorms. Looking at 12-month averages, the average 12-month rainfall since 2007 is about 9.5 inches. That's typical of a desert. The last 12 months, though, our average is 15.82 inches. That's because last year, in 2021, we got a bunch of rain in August and September. We got a bunch, much higher than normal. Much higher than normal. But if you look for so far in 2022, much lower than normal. Much lower than normal. So that total will definitely probably drop down in the summertime. Here is a map of kind of the Phoenix area and surrounding portions of Maricopa County. This is the mean annual rainfall, the average rainfall in 2017. Is that correct? I believe so, yeah. And so, or released in 2017. And so this looks at, again, average rainfall in our area. So in our area, so the green is 4.7 to 5.5 inches. Avondale, we're kind of right here in this, not quite, kind of hard to tell, not this green. So maybe like 6 to 6.5 inches is our average. As you get kind of more north of Phoenix, that those numbers go up. But as far as Maricopa County, on average, around 9 inches or so. So let's just focus on Avondale. So again, about 6 to 6.5 inches on average for our particular city, where Estrella Mountain is, which is right there. However, how much of this rain do we get during the North American monsoon? And so we're looking at anywhere from probably about 34 to 36% of our rain comes just from monsoon storms that were generated with the help of the warm, moist air being pulled in from the Gulf of California due to the monsoon. And you can see the further out you go into the desert, the higher percentage, most of the precipitation comes from this monsoon period. If we look overall, this is looking at precipitation, water. So this is precipitation just south of us, just kind of down near the river regions. So just south of us, south of Estrella Mountain, which is Estrella Mountain Community College, which is right about here. So on this graph, the blue is how much precipitation we get in a year. The red is how much precipitation we get from a monsoon. And this goes all the way back from 1989 to 2020. And you can see the blue line is getting lower, meaning that's less and less on average water throughout the year, as well as the red line is actually sloping down, meaning we're getting less moisture during the monsoon. So, due to climate change, that's probably to be expected. That trend is not really scheduled to change anytime soon. So let's go ahead and pause here. When we come back, we'll talk about tornadoes, or how people from where I'm from, Ohio, say it, tornadoes. See you back here in just a second.